Hello everyone, and welcome back to Reverse Engineering Linux 32-bit applications. In this video, we're going to continue our discussion of dynamic analysis. So in some previous videos, we set up an environment, we set up a sandbox and a virtual machine, and now we're going to go ahead and use a couple of tools in order to analyze our suspected malware a little better. So we go ahead and do this. I have my virtual machine already loaded. I'm going to make it full screen. And let me pull up a terminal. I'll make the font slightly larger. And let me go ahead and have a look at a couple of my programs, bind shell and reverse shell. So we'll start with bind shell. So the first program I want to use against it is called strace. As always, if I don't know exactly how to use a tool, I can always try strace -help. And it says, that's not valid, try -h. Okay, I will. And it tells me a little bit more about this tool. What are the different output formats, etc., etc. So I'm going to go ahead and just use the standard options. So notice that you have to eventually give it a program. So let's try that. I'm going to run strace against my bind shell and see what it tells me. So here is my output. Here are all the different system calls that were made. I called execv. I ran it, basically. And then I called open, memmap, fstat, close. And this will just show me various system calls. Now, ultimately, we're going to open this up in a debugger and have a look at it. But this is a good way to have sort of a high-level look at an application if you're trying to figure out kind of what it does. Now, when I run this, I notice that it just sort of exited fairly quickly. And you might wonder, why is that? Well, this might be because I didn't supply things like a password to my tool. Now, from our previous work, we know that this tool had a password of Swordman. So let's try rerunning it. And another thing I'm going to do is something super dangerous. I'm actually going to run it with sudo privileges too. So if I do a sudo strace on this executable, and I give it board man. Now I have some slightly different output. So again, it will show me what is being used here, which calls are being made. All right, so that is one of my executables down. And what about the other one? Well, the other one might be able to run. Now this one yelled at me and it said the bind failed. Notice that output right here. And it's telling me I was unable to bind to this port. Now if I pull open another terminal, I don't have nmap installed, but let me see if I can in fact connect to this port. Here it is. So I attempted to connect to this process. Notice that it was definitely listening on that port. And it asked me for my password. So let's try that one again. And here we are. So I was in my reverse shell and all that, but now it's a little bit unhappy because I've exited from there. I'll just go ahead and close that terminal. So we can see that it did, in fact, create this shell. And you can see the system calls that were made in order to allow that to happen. Okay. What about our other executable? Our other executable was this guy, a reverse shell. And it says usage reverse shell IP. Okay, so let me give it an IP address then. And the IP address I will give it is localhost. And it was still a little bit unhappy with me. It's telling me reverse shell and then an IP. So let's give it a numerical IP. And now notice it's a bit happier. So I can see what's being opened. I can see more things being opened. So here I see libc being loaded. I'm reading in my file, doing an fstat, memmap, etc., etc. So now I have a reverse shell, and I should be able to connect to this with netcat as well. So let's see if it works for us. And I can see that there's a process running there, but not quite using it the proper way, which is fine. Right? So, this is a early investigation into these tools. So that's strace. What about ltrace? What does it do? So ltrace is a library tracer. So if I do an ltrace -- help, it says it will trace the library calls of a given program. So let's give this a try. So I'm going to run ltrace on my program. And what does it appear to do? First, it allocates some memory, uses memset, put character, and then it opens Python. Uses fgets, Python 2712, does a stir, and then it does a fork. So it creates a new process, and then it exits. And it says bind failed, exit. All right, so let's see if we can get it to not fail. What if, like our other program, I have to give it an address? Still says bind failed. What if I run sudo on it first? All right, so this is failing most likely because I have another process already running on that port. So if I do a ps-user reverser, I see, sure enough, I've got this process running. Why don't I do this? ps-ef pipe to grep shing yi. And I notice that there are a few processes running. So I'm going to do a sudo kill 2263 2430 25. Well, that's my grep. I don't need to kill that one. Rerun my command, and now it seems happy. So let's go ahead and do this. And notice now it doesn't return, but it's also not complaining, right? It doesn't. Exit. So what if I do this again? What if I create a new terminal and I do a netcat? So it's what's the password? And notice that I'm root, because this was run as root, which is pretty cool. Let me just double check, make sure I don't have any lingering processes. I do not in this case. So now I can see the library calls that were made. Same thing with my reverse shell. And it says it failed to connect. So I didn't have a process listening for the reverse connection. So that's a little bit of an introduction to strace and ltrace. Again, these will allow you to see system calls and library calls. Not as powerful as running this through a debugger, but a good first step. And as an additional caution, just to remind you, don't run this stuff on your workstation. Run this stuff in a virtual machine that's disconnected from a network, ideally, and you'll be much better off. So we did a couple of simple things in order to better understand these executables. Now, if I had started out running this through a debugger, especially if I was tracing through with a debugger, it would have taken me a long time to figure out the proper command line arguments for these two programs. And it would just, suck up a lot of my time that I could spend doing some serious analysis. So here I've got an idea for what's going to happen. It looks like somebody is shelling out and doing a little bit of Python here. And I can also see which libraries are being loaded and which library functions are being called. So that's pretty powerful for a little bit of work. All right. So that was pretty much all I had to say in this video. As a reminder, this video is one in a family of videos that we have here at Pentester Academy, your source for all things InfoSec. And I would love to see you in this course or another course soon. See you then.